Working on a large Stuart model steam plant, this is part 9, boiler works. I've unbolted the Stuart HB6 boiler from the baseboard and it's just sat on there loose now. This safety valve has to go. I really do not like Stuart safety valves. I've never liked Stuart safety valves because they don't blow off cleanly, they just make a horrible noise. And personally, I think that they're ugly. They look like a piece of plumbing equipment. Very much like some of the girlfriends I've had in the past. I'm going to change this for a Jubilee Fittings pop safety valve. But before I do, I'll just show you what's inside. A massive spring and a stainless steel ball, which is currently stuck to the seat. Oops, I nearly lost the ball then. Here's a side-by-side comparison of the Stuart safety valve against the Jubilee Fittings safety valve. I know which one I prefer. These pop-type safety valves are made by David English at Jubilee Fittings. And I love the design. I'll show you what's inside it. The annular ring comes off quite easily with the help of a pair of circlip pliers, and then you can unscrew the middle bit, and here are all the parts. On this design of safety valve, I particularly like the shaft at the centre for two reasons. If the safety valve should continue to blow off after the pressure's dropped, you can tap the shaft to reseat the ball. Or alternatively, if the ball sticks on the seat, you can use a small pair of pliers to pull up the central shaft to free the ball. The safety valve of this type that I had in my box of safety valves of this type has the wrong thread. It has a 3/8 thread, whereas I need a 5/16 thread. This is no problem. I'm screwing the end back into it because I'm going to put this in the chuck very shortly and I don't want to crush the end of it. It's also held very firmly in the chuck. I could have used the hexagon part, but then that would have been marked. And here I'm doing something that a few expert viewers have written in to tell me that I shouldn't do. I'm using a 5/16 twist drill to initially set the micrometer. And yes, this may not be accurate, I am not entirely stupid, but it's a starting point. Normally I would use a drill bit for setting a micrometer because it's quicker than watching the graduations as you wind it out. Just simply wind out the micrometer, clamp it onto the drill, read what it says on the micrometer for the exact setting, then you can minutely adjust the micrometer to the perfect setting. This one from the drill was about half a thou under size. I do appreciate that an incorrect micrometer setting could be a problem in certain applications, but half a thou? For a safety valve thread, I don't think this is a big issue. Now if I was making space satellites it would be different, but I'm not. I'm making a thread to screw into a boiler. Time for a turning extravaganza. I'm turning this down to 5/16 of an inch in diameter. And I'm also going to shorten the length of the threaded part to make it the same as the threaded part on the Stuart safety valve. As usual, I'm getting the size right at the end of the part, testing it with a micrometer, and when it's okay I go all the way down. As usual, it's a nice sharp carbide tip tool and I seem to be getting quite a good finish. So now this is 5/16 of an inch in diameter. All I need to do now is trim off the end bit. And I'm very pleased to say that my lathe is working for a change. I've been having problems with it for a while, and periodically the contactor would just drop the power. But now since my friend Andy, the electrician, bypassed the contactor, it seems to be working fine, and the 3-phase converter is not going into boost mode. Time to cut the thread. I'm just using a standard hand tool for this, fitted with a 5/16 by 26 threads per inch die. I'm using the tailstock chuck to keep it square to the work at all times. I sort of follow it down the work. I could have put this die in my tailstock die holder, but doing it this way is quicker. Once again, it's not a precision part. Before removing the modified safety valve from the chuck, I just clean up the end with a file, so it's not sharp. Now I have a safety valve that will fit the boiler. It's a simple job to put it back together. First of all, I remove the end part that I fitted to stop the chuck from crushing the tube. Then I refit first the stainless steel ball, followed by the spring and the central brass shaft, and then I refit the end inner threaded part, followed by the locking ring. Even though this safety valve is going to be fitted with a copper washer, I'm still going to use some Loctite 542 to seal the threads. Not a lot of 542, just a small amount. And now, using my excellent Barco spanner, I screw the part in place into the boiler, and I think this looks better than the Stuart one. Into the outer part of the workshop now. This is my acid bath, and the acid is not strong enough to dissolve the bones that I've had in for ages. So I have a plan. Just leave the bones in the acid bath until they're nice and clean, then get them out and assemble them into full-size skeletons. Like this one. Just the thing for taking to Halloween parties. Back to the world of normal reality. This is the drain cock that was fitted to the water gauge. I fitted it, there wasn't one fitted as standard, just these square blocks. But it's always leaked, so now I'm taking it off. There was always a problem with the water gauge on this boiler from new. To seal the water gauge fittings against the boiler, they've used rubber washers or something, neoprene washers. Anyway, they're very perished, and there's movement on the water gauge, which is not a good thing. It's an easy and convenient way of fitting a water gauge to make it line up, but it's going to be very easily moved. I'd just like to say that I do not recommend using rubber, neoprene or silicone washers on water gauge fittings. These fittings need to be really solid. I mean, look at the state of this washer. It has little structural strength, and in no time at all I can pull it apart with my fingers. If I stretch it out with a pair of pliers, you can see how badly perished it is. It's almost ready to break anyway. And do bear in mind that this was a brand new boiler that came direct to me from Stuart Models. And I don't like the simplistic square design of the water gauge fittings anyway. For a boiler of this quality I would have expected better. As you can see, the bottom part of the glass has been broken. And this has been broken because the bottom fitting must have moved as the previous owner blew down the water gauge with the drain cock. All is not lost though, I have a plan. In my box of spurious water gauges, I found this. This is a Stuart water gauge. It's new old stock. And also it has a union coupling on the end of the drain cock, so I'll be able to pipe the water away from the baseboard. I'll be fitting this in the next episode. And until then, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainstream Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.